Here we see that same nurse again pushing a chair. When the nurse pushes the chair, there's a force applied to the right. The displacement is to the right, and so the nurse is doing work on the wheelchair. When work is input into a system, when you do work on a system, it changes the speed of the system, and and therefore it changes its kinetic energy. We have two very related concepts here that you might not naturally think are related. Remember that heat is actually a transfer of thermal energy. So get it out of your head that heat and temperature are the same thing. They're not the same thing. Heat is the transfer of thermal energy from one object to another, from one location to another. Work is also a form of energy transfer between a system and its environment. So, work and heat are very closely related topics. Work is measured in joules and it's equal to the change in a system's kinetic energy. So, work is equal to the change in kinetic energy, or that can be expressed as W equals delta KE. That's something that can go in your notes. Work is a change in kinetic energy. A force in this direction of motion adds to the kinetic energy of a system. So if you're doing work, if you're applying a force in the direction of motion, then you're doing work on the system. You are adding kinetic energy. If you do, if you apply a force against the direction of motion, let's say if a car is moving down the road and you hit the brakes, then the brakes apply a force against the direction of motion that will decrease the kinetic energy of the system, and you're doing a negative amount of work on the car, or you are um, yeah, you're doing a negative amount of work on the car. You're decreasing the kinetic energy. Conservation of energy accounts for all energy transfers into and out of the system. Any energy input to the system will raise its internal energy, while any energy output will lower it. So we need to monitor if we want to know, if we want to have a good idea of energy transfer, we monitor changes to internal energy. The energy that a system releases as useful work is limited by the amount of energy it has. For example, when a battery is fully charged, energy is stored as chemical energy in the battery. The energy, this energy, it's the system's initial internal energy. Okay, so the battery has internal energy in the form of kinetic energy, and then as it's used to power a device, like if you put it in a fan, the chemical energy is converted into kinetic energy. The kinetic energy is limited by the system's initial internal energy. So the a battery cannot provide more energy to a fan than it has. Uh, if you talk about making a car engine more efficient, the the gasoline and the gas and air mixture cannot provide more energy to the car than it has in chemical energy. So there is an upper limit to how much energy can be produced by any system. To predict how much longer this battery powered fan can run without recharging the battery, you need to know how much energy is stored in the battery and how much has been used as output. We'll learn more about this when we learn more about electricity and exactly how energy works within an electrical system. So let's say you have a force doing 40 joules of work on a system, but at the same time, 40 joules of heat leaves the system. What is the change in the internal energy of the system? Well, in this case, all of the internal energy is going to be, I'm sorry, in this case, the force does 40 joules of work, but 40 joules of heat leaves the system. Well, in this case, the uh, the all of the energy that's going into the system as work is going out of the system as heat. Okay, so 40 joules is transferred into the system, 40 joules is transferred out of the system. So the net change of internal energy is going to be equal to zero. And this is a calculation that you do uh, for, for to find the change in internal energy. Is you take the amount of work. So work is a type of energy transfer. You can take the amount of work and then subtract the amount of heat. Heat is another type of energy transfer. And then whatever is left over, that's going to be the change in internal energy of the system.